How do we find increasing and decreasing interval when the equation is given to us in quadratic form? Here are three examples which we are going to explore, and that will reveal three different methods for doing the same. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting admission to the best universities with scholarship. Now let's explore how do we figure out increasing and decreasing interval for quadratic functions. Here are three different equations given to you. The very first one is in the vertex form, second and third are given in standard form. Well, as you know, parabola is the graph for any quadratic function which can open downwards or upwards. So clearly, from the vertex, the increasing and decreasing intervals are defined. So as you can see in the first graph, it is increasing from minus infinity to the point where the turning point is there, and thereafter it is decreasing. If the parabola is opening upwards, then it is decreasing from minus infinity to the axis of symmetry, because at the vertex also we have axis of symmetry. So that is the basic concept. So now basically the idea is to find the vertex, yes, and second, whether the parabola opens upwards or downwards. Keeping that in mind, we are going to solve these questions. Here is question number 1. Let's rewrite the problem, which is y equals to 2 minus x minus 1 whole square. So, if I write it in proper way, that is minus x minus 1 whole square plus 2, we can clearly see what the vertex is. Let's say the vertex v will be at 1. Maximum value is going to be 2. Since the leading coefficient is negative, parabola is going to open downwards. Makes sense, right? Well, as a part of practice, you must have noticed by now, real problem is to sketch the graph and then write increasing, decreasing interval. So once we have this vertex, which is at 1, the y value is 2, right? There you go. We can now, since we know that it opens downwards, we can adopt the steps. Step 1, 1 unit down, then 3 units, 1, 2, 3, and then 5, 1, 1, 2, 3, 4, 5. Now, on the other side, because the symmetry, we can get the points very easily. Connecting them, we get a graph, right? So that's the parabola represented by the given equation. Where, let me rewrite the vertex v as 1, comma 2. And that gives us increasing and decreasing interval. So initially, the graph is increasing from minus infinity to x equals to 1. And then it decreases from 1 to infinity. Is that clear to you? So the idea is to find the vertex and whether it opens up and down, and then write down increasing and decreasing interval just as we have done. So I hope this concept is absolutely clear. You can now pause the video, answer the next question. This is slightly different as this time the equation is given in standard form. F of x is equal to x squared minus 4x plus 4. Couple of ways to do it. The easiest for this equation will be to factor it. While this is also a perfect square, I can write this as x minus 2 whole square, correct? Since 4 is a perfect square. So this trinomial x squared minus 4x plus 4 can be written as x minus 2 whole square. That gives us the vertex as at 2 the value is 0. So 2, 0 becomes the vertex for us right there. And again, we can make the parabola with using the steps, or you can also use table of values, right? So next step of 3 and then 5. 1, 2, 3, 4, 5. And then from symmetry, you can get the other values, right? Connect these points with a smooth curve. There you see, we have the turning point at x equals to 2. And therefore, we can write down increasing interval and decreasing interval. So can you tell me which is the increasing interval? The parabola opens upwards since the leading coefficient is positive. Increasing is from the vertex to infinity. So it is from 2 to infinity, right? And the decreasing interval is from minus infinity to 2. Perfect. Let's take up the third example now, which is again a standard equation. This cannot be factored. So what should we do? To find the vertex, we can use completing the squares method and then we can solve it. We know this parabola opens upwards. Perfect. Since the leading coefficient is positive. So let's do completing the squares. Half of 6 is 3. So we are going to add 3 squared and subtract 3 squared. That gives you x plus 3 whole squared. So these are the first three terms. And then we have minus 9 minus 1, or we can write this as x plus 3 whole square minus 10. So this time the vertex is at minus 3 and the y value is minus 10. So minus 10 is beyond the graph shown here, let's say about this point. So at minus 3, let's say that's the parabola vertex. And going with 1, 3, 5, 7 steps, we can draw the parabola as shown here, right? Perfect. So that is good enough to give you increasing and decreasing intervals. So clearly here it is decreasing from minus infinity to minus 3 and is increasing from minus 3 to infinity. Is that clear to you? So that is how we are going to solve this particular question. Now here is a shortcut method to do this same problem. Well, to find the vertex, remember, we need to find the axis of symmetry, right? For any quadratic equation which is of the form y equals to ax squared plus bx plus c, the axis of symmetry is at x equals to minus b by 2a. So this formula can be easily utilized. So if I use this formula, x value minus b is minus 6, 2 times 1 is 2, will be at minus 3. So definitely, we know that the axis is at minus 3, right? Since the parabola opens upwards, we have the graph going like this. And clearly, we can say that it is decreasing first from minus infinity to minus 3 and thereafter increasing from minus 3 to infinity. So in this case, you do not have to do completing the squares to find the vertex. I hope that makes sense. So that's the tip of this particular video. I hope that helps. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.